Hi, this is Professor Loushine. Welcome to the first step or the second of 8 videos I've created to demonstrate my technique for analyzing, well, any type of injury or safety related data, but this one is specifically toward loss run data analysis. So to begin, the first step is to assess the overall data set. Now, depending on where you get your data from, what type of data it is, or who your work comp carrier is, it's going to look a little bit different, and that's okay. But I'm going to provide you with 4 different samples that we'll look at, and then you can apply it to your own. For my students, it's what you're given. But we want to look at the header row, and that of the variables or the characteristics of the claim. Look at the range of dates that are covered. Ideally, you have 10 years worth. The number of entries. Then we're going to fill out this table, which I call descriptives. And then finally, we're going to look at a distribution chart of the data. Here are the 4 samples I pulled from. I've got partners in industry who have been kind enough to share some loss run reports with me. I'm going to try to keep them as nondescript as possible. I don't want to get anybody in trouble, and I'm not going to share anything personal on the data sets themselves. But you can see I've got 4 different industries represented. I've got different time amounts. Some are 10, some are less than 10, but it doesn't matter because it's the technique that I'm trying to show you. There are going to be some different skills that I want my students to at least develop. With Excel, I'm going to be using macros, which are Control-C for copy, Control-X for cut, Control-V for paste. To back up one move, which I call the whoops macro, is Control-Z. And then finally, to repeat a move, it's Control-Y. So I'll be going through pretty quickly, but this is what I use to make it go quicker. It's just what I feel comfortable doing. In order to move entire spreadsheets from one tab to another, we highlight an upper left-hand corner, and I'll show that as well. Sorting, I'm going to be using the filter header row. To insert a column, it's a click on a column, which are the letters, and right-click and insert column. Auto copy paste. I'll show you this as well. When you click on a cell, there's a little black dot when you put the cursor over it. If you click on it and drag it, it copies and pastes. If you double click on it, it copies it all the way down to the end of the data. And then finally, how to manipulate cells as far as font, alignment, border, format, shading. These are the things I do really quickly, just because if you want to call it OCD, I want to keep everything nice and clean and pretty. The analysis formulas we're going to be using to add columns is the sum range, and you're going to see this. I calculate percentages, in which I click on 2 different cells or enter in a total amount. Counting if a particular criteria is in another column. Taking the average and median, we take the maximum. I don't do the minimum because we've got 0. And then finally, to create a chart, and I'm going to do that as well in this video. So let's look at the data set. So here is my spreadsheet. I've got companies A, B, C, and D, and I've already created the tabs that I'm going to be working on because I'm just going to show you how to do one, and then we're going to look at the results of the others. So first, let's look at the headers. And I will zoom in a little bit, and this is going to be the tough part, I believe. So, starting with A, and again, these have been manipulated a little bit just to make it a little bit easier to look at. So whatever you get from your comp carrier, ask for it in Microsoft Excel. I'm working with, I think 2013 Excel version. You may have to change some of the things I talk about here. It depends on what you're working with, but it can be done. So the header row, we've got date of injury, gender, their date of birth, when they were hired, time of injury, whether the accident was in AM or PM, receive date, that's when they filed the claim, or when they filed that they got hurt. Nature, which is sort of the prognosis. Body part, accident source is like cause. Submission description is something we're going to look at when we do outliers. Policy class code, which is what your state compensation rating board is going to use, because you take whatever rate a particular class code has multiplied by payroll divided by 100. That is the individual code's base premium, and you add it up for a company. The jurisdiction state, so this is Wisconsin, whether it was a medical or indemnity. In Wisconsin anyway, if it's medical only, the amount counts at 30% of what the amount is towards your EMR. And then we've got paid medical, paid indemnity, paid LAE. Then we got reserves and then total incurred. And I think that's the, oh, we've got some extra stuff too. Then we've got the close date and we've got whether it's open or closed. So for B, I'll kind of zoom this in as well. You'll see a lot of similar entries. Oh, this is new. So I added a number because later on I'm going to use pivot tables to do some shortcuts, and you need a unique identifier. Now, your data that you get from your WorkCom carrier may already have a unique identifier, but I deleted try as much of that stuff as possible, and so I added my own number. I'll be creating the fiscal year in the master A, and also a total paid. But as you can see, the headers are somewhat similar. Here we've got accident location, accident department. We'll have similar things in all of our data. Again, I added the unique identifier, just a number, 1 through the total. And you can see a lot of similar. It's similar, but sometimes the columns are a little bit different. So don't copy exactly what I type in, because your data set may be a little bit different. And as you can see here, again, much of the similar entries. See, this one is a little bit more. They've got reserve and incurred and recovery, and the claim descriptions are at the end. So 4 different data sets. So the first step is I'm going to start working with the A master, and hopefully you guys can follow along. Hopefully it's big enough that you can see it. So the first thing I want to do is I want to create a unique identifier. And this is because what I do is after each step, I copy and paste that to the next one, except when we do the distribution. That's going to be a standalone. And usually I don't manipulate the master, but for the sake of this video, I try to keep the master in its pristine raw state so that if I have to go back to it, I can. But so do as I say, not as I do. So I left click on A, right click to get this menu, and then I go insert. It gives me a column. I type in the header what it is, and I'm just calling this number for no other reason. And then I start a series, 1, 2, 3. Luckily, it's already in general. Now, this Excel sometimes guesses. They may have it in dates. And so what you'd have to do is go up and copy and manipulate it and turn it into a general number, but I've already got that there. So I highlight the way it's going. I double click. I right clicked on the that little thing that was down there, and what it did is it went ahead and filled it in for me. Isn't that nice? So sometimes that's good, sometimes it's bad. Excel tries to think ahead a little bit, and sometimes you get in trouble with it. Next, I need to put in whether it's a calendar or fiscal year. But before I do that, I need to sort, and I shouldn't have put that in first. No matter, I can redo it. So what I'm doing is I'm highlighting the header row, and then I go up to data, and then I click on filter. You see data tab up here, and then I'm left clicking under filter. And what it does is it makes the header row the starting point in which to generate a sort for the entire data set. I have nothing down below. If I had something down below, it would bring that into the sort, but I don't. So it's just the way it is. I need to sort by date of injury because I need to set up my own annual. I'm going to sort A to Z, and there we go. So I've got, I guess it was already sorted, but for this, I sorted it for you. It starts July 5th of 2012, and it goes through January 23rd of 2019. Because it begins mid-year, I'm going to use a fiscal year basis for my annual assessment. If you begin January 1st, well, then use calendar year. I mean, it's just an arbitrary 365-day round. So I'm going to go and put fiscal year. And I'm going to manually enter these. So I'm going to start with 2012. Oh, see, it changed it into a date, but I don't want a date. So I'm going to go up into the format. See, it says date. I'm going to go general, and it's just giving me the 2012 because that's what I want. You'll see later. So I click, you see this little button on the bottom right-hand corner. When the cursor goes over it, it changes. So when I left click and drag, it drags it with. Now, if I had 2 consecutive numbers, it would try to turn it into a series, but it's not. What I'm looking for is 630, or as close as I can. And there's one fiscal year. 2013, it did it again. So let's go ahead and go general again. I'll click on it, and I make sure it doesn't try to make a series. Okay, there we go. 2014, it's probably going to do the same thing as before. I could have changed the whole thing, but I'm trying to demonstrate here. So now I'm looking for 06, 15. All right. I'll change that again. I mean, Excel tries to make it easier by guessing certain things, but they don't always guess right. They guess right about as much as we do as humans. I'm almost there. There's going to be some manual work in my technique, but I've attempted to minimize that. And I'm going to try to show you shortcuts as well. 2017. Okay. I think I went by it. Yep. There we go. Fortunately for you, I did these already for all the other 3 data sets. So I'm just going to demonstrate on one, and then we're going to look at the results of the others. All right, so we never even finished. So this is an unfinished year, fiscal year 2018. That'll become important later on. Now, I think there's one more thing I need to add before I start working on that table, and that is to create a total paid. Now, total incurred is a combination. It's sort of an accounting type thing where if a claim is still open, there's going to be still stuff paid on it. And so they'll have reserve here or what recoveries, things like that. I'm only concerned with what has been paid. So I'm going to insert a column. I'm going to type in total paid. And this is going to be... Now, in order to fill this in, I'm just going to add up what was paid for medical indemnity and LAE. And so I type in an equal sign, and then I can either type in sum and then identify the range, or I can click on the cells that I want to add. It's the same. It's 6 versus half a dozen. So that's the total of that. And then if I put the cursor here and then double left click, it fills it in all the way down to the bottom. See? Isn't that quick? It's cool. So now I'm going to bring the header row down to the bottom so I know what I'm working with. Oh, and one thing, I always put in an open row here, so I could still use the filter, but because of the break here, it shouldn't mess what I'm working with down below, though I'm always careful to check that out. So the next thing we need to do is bring over that table. Now, I showed it in the PowerPoint. I've got another copy here and another, and I'm just going to bring this over, just a copy paste. Actually, why don't we bring this whole thing over? And I'm going to put it under the one before the paid medical. Okay, so paid medical is right here. Put it one over, put some space here, and paste. Now, yeah, it's, as you can see, it's like it has a problem with it. Of course it does, because we had built it with that other with the data or the setup on the other table. So you have to work within the spreadsheet you have. The first thing I could do here is quick figure out the open close. So open and closed is Z, and Z goes down to 498. And in here, I need to type in. Sorry, the microphone got in the way. Equals count if, and the range is Z2 to Z487, and we should see it light up. See that? See how Z lit up there? And I gave it a range. It lets me know what I'm working with. Count if, what I wanted to do is I want to count the number of open. So whenever that phrase appears in that range, it counts it for me. And I need to figure out the percent by putting in how many claims are in this data set, which is 486. I get a percent. Now, I want to click and drag this. I don't have to, but I want to. So one thing I do is I freeze. Whenever you're going to click and drag down, you have to freeze the row numbers. If you're going to go left or right, then you freeze the column, unless you want it to do that. Wait. You know, I did that wrong. I need to, for this one, I got to put open, or close rather. There. And because this is, that should equal 100. It does now. Sorry about that. Sometimes I got to catch myself. So, I got to adjust the mic here because I'm going to do a lot of typing. So, in order to fill this out, I really only have to type in the equations I need for the one here on the left. Excuse me. Kind of blow it up here a little bit more. And then I can drag it over as long as I freeze the right ranges. So the subtotal is equal sum. So that means add up. And so I need to give the range. And so I'm going to go Q2 to Q487. And I'll scroll up quick. You can see. So what I'm doing is I'm adding up this row. That's what I asked it to do. Equal sum and then gave it the start and end range, so Q2 cell to Q47 cell, hit return. Oh, and it gave it to me in dollar value. Sometimes it doesn't do that. I got to go fix that. So that's the total amount of medical paid in this particular data set. Bring it over, and the total amount for this data set is 1.5 million, which, as you're going to find, is actually a pretty low amount compared to the three other samples I have. So percent total paid, I'm going to take the subtotal and divide it by the total paid, 1541971. It gave us a percent. Sometimes I have to change that. I click and drag it over. There we go. Average paid, type equals average, Q2, Q to Q47. It's in a dollar value already. A lot of these you have to actually enter it each time, but this is going really nice and quick for us. Equals median. The median is the 50th percentile. So if you're to go by a count, it's the halfway count. If you have a perfectly normal distribution, the mean and the median are going to be the same. If they're not, then we need to evaluate the distribution of the data to find out which way it's skewing. It is different. So I'll be looking at the distribution in just a moment. The number of $0 claims. So I think the way a data set kind of sets up where whether it's a $0 claim or a super expensive claim, that steers us, that biases or skews the average and medians and things like that. So I like to look at it from both ends. So sort of the outliers on both ends. So count if Q2 to Q47, if that is a 0, count it. Again, I didn't have to change the cell type, which is nice. The percent of $0 claims is the count divided by the total count, which is, it's not 1522. I got to change that. 486. Because there's a header row. So 487 is the bottom divided by 486. I'm going to change that right away. That would have screwed me up if I had just used this. 486. Now I can double check that because I put in the unique identifiers, and it's right there, 486, just so you could see. Paid only claims. So these are the claims in which only money was paid, and kind of removes the $0 claim. So I take the total amount paid divided by 486 minus the number of $0 claims. And it usually goes up a little depending on the number of $0 claims. There you go. The max amount paid for each subtotal paid amount or each benefit, just type in max and Q2 to Q487. That's the max amount. And now we go to how I want to know what influence this particular max amount has on its total. That'll become important later when we start doing risk priority numbers. There we go. So what did we learn about this particular data set? We have 486 claims that go from a 2009 to a 2018. So it's not a full 10 years, but it's a modified. 3.3% are still open, and when we get into the annual analysis, we'll find out where those lie. As far as, can we use the final year, or the final 2 years, or is there too many open claims? Then we have what the total amount of the data set covers, what the average claim was, what the median claim was, what if it was paid, how much it was, what percent are $0 claims in the overall, and then what is the max amount and what is its influence. So 8.3 is a heavy influence. That if we kept the outliers in, the real expensive outliers, that would bring the location and cause to an automatic high priority. So I remove the outliers, that doesn't happen. Let's look at some of the results of the other tables. So in this particular data set, we had a little over 1,500 claims. Total was 6.3 million. The average amount paid was about 4.1. The median is much lower. We had 120, which is about 7.9% of the 0 claims. The paid amount is a little bit higher, and this is the max paid. 3.3, it's small, but still we'll be able to take a bunch of the top ones out. Number of open claims, 65, 4.3%. This particular set, let's see what we get. So we've got 948. I just want to make sure. Yep. Wait. Yeah, 948. It should be 947, shouldn't it? Oh, wait. 948 is the number. Yeah. 948. So I got 948. Sorry. We're back. The total amount is about a little over 2.1 million. Average paid about 2,200 something. Here's the median, it's lower. The number of $0 claims, it's a higher percent. The max is a little over 151,000, and it's about 7%. About 4.75 is still open. The final data set, I think this is the largest of our data sets that we'll be working with. There it is. Looks like, so we've got a little over 3,300. The total amount is 14 million and change. So this is much larger. Average is about 4,300. The median is almost nothing. It is in everything else. We have a lot of $0 claims, which is why this is driven down. The most expensive claim is over 1.1 million. It does influence, even though we've got bigger amounts. So as you can see, we're going to be removing outliers. It's just got to figure out how many we're going to remove. And then just under 2%, or about just over 1.5% are still open. So again, that'll become important when we do the annual trending. So first step, let's look at distributions now. So what I did here is I created this table which I can copy and paste above the original data set. And what it does is it counts by range. So anything below $500, anything below $1,000, and then I create a difference here so I know how many counts are in each range, and then I track what percent it represents. And I went all the way up to 50,000 because this took a while to build. And then I've got, again, 4 over 50,000. It's a small percent. So let's look at the distribution because, again, like I had mentioned earlier, if the median and the mean were the same, we'd have a nice normal curve. Here we do not. And I did not plot the $0 claims because they kind of have that basement effect. It's more asymptotic than anything. Again, the median is going to be somewhere in here. The mean is somewhere out here. So we've got some weird, the outliers that are more expensive are drawing it one way. The $0 claims are drawing it the other way, but it doesn't balance. So we have to be careful if we were to run any form of parametric statistics on this data. Let's look at the C distribution, and then I'll show you how I calculate how I did this whole thing. So our C, it looks the same. It looks very similar. Oh man, I can't get this on the screen. Where a majority of our claims are very, very low. And then we've got $0 claims, and then we've got some expensive ones. So when we start talking about averages and everything, that's not an accurate depiction of what's going on. Yet whenever we try to find out what's the average cost of a claim, we get a number and we just assume that it's the 50th percentile. As you can see, so we have some really expensive claims here. Once those come out and once we factor out the $0, we'll get a better look at things. But as you can see, this is a much more expensive site when it comes to work comp. And it'll become more evident when we start looking at outliers, which is the next video. So let me show you how I did this. I believe I did it with my B. I haven't done it yet. So I bring over an entire data set by left-clicking on this upper left-hand corner, kind of like the apex between rows and columns. And I do Control-C to copy. And then I go to the next, and I go in A1, and I go paste, which is Control-V. The way my demo table works is I need to insert all the way down to the header row needs to be on row 105, and then I'll copy and paste it over, and I just have to do a few other little tweaks. I'm using Control Y right now to repeat, to send it down, and I got to scroll down and see where we are. I'm going to insert some more, try to bring it all the way down to 105, which has got to be getting close here, and 2 more. And 1 more. There. The other thing I do is I delete everything that's down below just to make sure it doesn't end up in the analysis. Delete. So I'm not going to be copying and pasting this tab ever. Next thing you need to know is where is the total paid column. Total paid is V. All right, so let's bring up my demo. So I created this table, and this is something I can share with people too. So move the data set down to 105, copy and paste, so total count is directly, this is total count, is directly above total paid. Again, we looked at that again and it was Q, and then go ahead and paste it on over. So I'm going to go and copy this. I got to go 2 over from Q. I'll double check that just to make sure. So total paid, oh, it's V. Okay, so I got to go 2 over from V. I'll go up. Here's V, 2 over. I'm on row 1, hit paste. So it went through and added up everything for me. The total N in this data set, I'm going to check it. It is 1522. This is different from the one I worked on before. I'm going to be flipping around just to keep you on your toes, but the technique is always going to be the same. So now I want to kind of monitor the count, and so I'm going to take what was added up and divide it by 1522. Again, this is the percent that is covered, and I want to see when it gets to the end. So I'm turning this into a percentage. Hit return, go on here, double click it. And as you, oh, geez, that goes really quick. In this particular data set, up to 50,000, we've got about 98.5%, and then we've got 23 claims that are above 50 grand. So let's graph it, see what it looks like. I'm going to be graphing the range count, but I'm not going to do the zero mount. I'm going to highlight these numbers. Okay, highlight it, and then I go to Insert, and I go to Bar Chart. Choose that, and here is my chart. And I'm going to try to bring it up top here. I'm just doing a simple click and drag. Excel doesn't like to go very fast when you're moving something like this. Come on, come on, come on. We're almost done here. Let's go. There we go. So put that up in the corner. This thing does not like me. All right, there we go. And the next thing I want to do is I need to manipulate down here. I needed to have the actual ranges. So I right-click on the data and go to Select Data. Now this is how I manipulate my chart. I go to Edit for the horizontal or X-axis, and then I just got to click on 500 and go up to greater than 50,000. And let it in. Hit OK. Hit OK. And now, there. So now here is the distribution. So that's how I got all those other distributions. So this is the count of claims that were below 500, and then the ones that were 500 to 1,000, and 1,000 to 1,500. You can see we still have this interesting form, which is almost asymptotic. You know, as you go to 0, it goes about infinity. But as we come down, there's just this, you know, there are there's these sporadic, expensive claims, and that's what's really affecting our average and things like that. And so again, when we see the average amount, it's 4,000 something, but the median is under 1,000 or between 500 and 1,000, and you can see that what it represents. So now it just gives us more insight into what the data looks like, and therefore what does it mean as we move forward. So again, we had looked at the distributions here. They have very similar layouts, but what's going to be really interesting is when we look at outliers and what we're going to remove as we move forward to do the analysis. So that wraps it up. That wraps up this step. So please stick with me. Again, this is Professor Loushine, and in the next step, we'll be looking at outliers.